In the last class we talked about linear regression, or we simply call it as regression analysis. Now in this class we will be talking about logistic regression. What exactly is logistic regression, how it is different from linear regression, what are the new concepts that we are going to discuss inside logistic regression that are not there in linear regression that we just finished. In this particular session we are going to discuss about what is the need of logistic regression if there is already one linear regression available, how do we build a logistic regression line, what are some of the goodness of fit measures. Once we build the regression line, how do we make sure that the line that we just built is best fit for our data, some of the goodness of fit measures, and then what is multicollinearity, how it is treated inside logistic regression, what is the difference between multicollinearity of linear regression and the logistic regression, how do we measure the individual impact of the variables in building a logistic regression line, how do we make sure that each variable is impactful, or how do we identify the variables that are not impactful. Then if there are multiple models, how do we select the model selection and validation. That is what we are going to discuss in this particular session of logistic regression. We'll start with basic concept. What is the need of nonlinear regression? Even before that, what we'll do is we'll try to do a quick recap of what we learned in linear regression. So how do we fit a linear regression line? If we have a data of a predictor variable, let's say that is x, that is trying to predict a new variable, that is trying to predict a dependent variable that is depending on x variable. Let's say there are two variables x and y. We are using x to predict y. Here we'll try to do a recap of linear regression by simply building this model. There is a simple data set, product sales data. In this particular data set, what we need to do is simply there are two variables, that is bought versus age. Like some people bought a product, some people didn't buy a product. So bought takes two values, that is yes or no, and we also have the information on the age of those customers. So depending on age, customers are buying or not buying. What we need to do is simply predict whether a customer will buy or not buy depending on age. So we need to build a regression line between buying and age. So we just need to write y equal to some function of age, that is y is buying. Then we'll see what is r square value. Then we have to predict if the age is 4, whether the customer will buy the product or not. If the age is 105, whether the customer will buy the product or not. So simply we need to build a simple linear regression line just as a recap of the linear regression that we just finished. So here is the product sales data. Here is the product sales data. As we told, there are simply two observations, that is age. There is age slightly ordered, and then some people are buying the product, some people are not buying the product. So 1 means like maybe buying the product, 0 means not buying the product. There are some products which you can predict whether a person is buying or not buying depending on the age. So that's a simple data set. It has 467 rows and 2 columns, that is just buying versus age. This has 2 columns, age versus buying. What we are planning to do is we are planning to predict bought, like buying, depending on age. Simply we have to build a linear model. We have seen already linear model, y versus x, and then the data set is product sales, and then we are storing everything in product sales model. Then we'll see the summary of the model. Here is the summary. You can do along with me. Simply you build the model, you pause the video, you build this model, you import this data, build this model. You should get the same value. R square, adjusted R square values are 84%. Looks like a fairly good model. Using age, I am trying to predict buy, and using age we are trying to predict whether a person will buy or not buy, and we just built a model for that. Then what is the next question? If the age is 4, whether that customer will buy or not. So we are substituting age equal to 4 and then we are trying to predict using the model that we have just built whether that person will buy the product or not. By the way, buying is maybe, let's say, 1, not buying is 0. So using age, so this product sales has two variables. If you see that, if I have to simply see product sales dollar bought, if I have to create a table for that, you can see it has just two variables, that is buying versus not buying. Like there are some people who did not buy, there are some people who bought that product. So we just need to predict 4-year-old customer whether he will buy the product or not. Age equal to 4. What is the predicted value of buy? The predicted value of buy is minus 0.8664394. Now that is strange, because buy, this variable, this particular variable takes just two values, 0 or 1. What does negative value mean? Is it buying or not buying, or anti-buying, or buying twice, or persuading people, or impacting people, or telling people not to buy? What exactly this negative sign mean? Okay, that's fine. Let's go to the next one. Okay, keep that, hold it. Next, go to the next prediction. What is that? Age equal to 105, whether that customer will buy or not buy. So if it is 1, prediction is 1, then he will buy. Prediction is 0, not buying. What if age is 105, whether that customer, what is the predicted value of using the linear model that we have built? The predicted value for age equal to 105 is 2.02. What does that mean? Because buy takes only two values. Our y variable, our dependent variable, it just takes two values, 0 and 1. We are predicting something as 2.0. Does that mean he will buy two products? I don't think so. There's something wrong. There is something totally wrong that we are doing. Let us see what's wrong we are trying to do. See, if you draw the data set, okay, or simply let me just clean it up and let me just draw the data set. This is our data. It just has two variables, buying versus age. Age is on x-axis, buying is on y-axis. And you know, buy takes only two variables, two values, that is either 0 or 1. So buy takes only two values. On the y-axis you will have only two values, either 0 or 1. That's it. So how many times buy is taking 0? This is like up till like when age is 0, or like when age is 1, 2, 3, 4, 10, 12, 13, 20. Till that point most of the people are not buying this product. Maybe it is not related to them. There are some people who are buying this product. Now age 40 onwards, lot of people are buying this product. Now that is the original data, and if I just draw the regression model on this data set, it just looks like this. Now the regression model that we fit for the same data, the regression model, look at this carefully, observe this regression model carefully. The regression model, the regression line that we just fit above the product sales model is this. Don't you think this is wrong? Why this is wrong? Because it is not good for fit for this data. We are trying to fit a straight line for a non-linear type of data. The y variable here, buy, has just two values. It just takes two values, that is either 0 or 1, buying or not buying, yes or no, true or false. That's it. When the data is arranged like that, when the data is non-linear, you can't force fit a linear regression line. So fitting a linear regression line for this type of data is wrong. When the data is non-linear, you remember our linear regression line, how the data used to span, as x increases, y used to increase. Y never took just two values, 0 and 1. Y never took like that, right? The variable y, it never took just two values, 0 and 1. It was always continuous. If x variable is continuous, y variable is continuous, then you can go for linear regression. If the relation between x and y is linear, then only you should fit linear regression line. When the relation is not linear, There is no point in fitting a linear regression line. So that is why we are getting wrong results. That's the reason why we force fit a linear regression line. That's why when we used it for prediction, we are getting values that are totally absurd. In fact, this line fitting for this data itself is not correct. We are doing something totally wrong. Now you understood the need of non-linear regression. So the model that we built for this data is not right. There is definitely certain type of issue of the dependent variable. Here dependent variable is the y variable, right? Y. The dependent variable, the buying or not buying, depends on age. The dependent variable is not continuous, it is binary. It just takes two values. So we can't fit a linear regression line to this data. That is the reason why we have to go for something else, something other than linear regression line to this type of data. What is it? So linear regression line for this data is wrong. We just can't fit linear regression line. Blindly we just can't take the data set, and if somebody asks us for fitting a regression line, we should not go for linear model directly. We have to make sure that the relation between x and y is linear, or we can fit a straight line. The relation appears to be a straight line, then only we should go for linear regression line. Otherwise we should not go. So why not linear? Why not linear? We know that, right? Because the relation is not linear. Age is continuous variable. It is varying between 6 and 80, or like their age is continuous, right? We have seen in the data age takes 2, 3, 4, 5. It is continuous. Whereas buying is not linear. It is not continuous. It just takes two values, 0 and 1. That's it. No matter what you do using regression line, linear regression, no matter how much you try, no matter what optimization you use, no matter what you do, you just can't force fit a straight line to this data. That's why we should search for something other than linear. In fact, in real life you will see so many such examples. In gaming, winning versus losing. In sales, buying versus not buying. In marketing, whether a customer will respond versus not respond. It might depend on several factors like what type of call you are making, what type of product you are selling. In sales, customer buying and not buying might depend on so many factors: customer buying patterns, customer's age, customer's gender, customer's location. In credit cards, default or non-default, a customer will pay back the loan or not might depend on so many things: how many loans he has, what is the salary. In operations, attrition versus retention, attrition, non-attrition. In websites, clicking versus not clicking on a web ad. That might depend on so many factors. In fraud identification, fraud versus not fraud. Healthcare, cure versus no cure. There are so many such real life examples which are not linear. The y variable just takes two values, 1 or 0, true or false, -1 or +1, just two values. There, fitting a linear regression line is not the solution. So we need to look for something else. At least for now you can confirm, or you can be satisfied that at least now you should agree that fitting a linear regression line for a non-linear or a binary output, the linear regression line is not the solution. We are doing something wrong. We have to look for a better solution or a better fit for this data. Linear line is not a good fit. Linear function y equal to beta naught plus beta 1x is not the correct function. There must be some other function we should be fitting. What is that? Is the question.